Hi, everybody. Welcome to my presentation on TAP application accelerators. Make developing great again. Just a quick note before we begin. We have a lot of material to cover through, so if you have any questions, please drop it in the chat over here or over there, depending on where it is on your computer. And I'll be addressing questions from there and any at the time at the end of the presentation. So without further ado, let us begin. As a developer in a company, have you ever started a new development project with a sense of dread as you contemplate where the heck you should begin? Your mission is to just start writing code, and yet, how do you start? So you probably check to see the Git repository, the company has one of those, and you look to see examples of code there that you might be related to the project. And then you need to then reverse engineer what's there. But it's just so overwhelming, the sheer volume of code and files to trudge through. It's confusing file structure, outdated documentation, redundant code, legacy code, and then Dockerfile, deploy.yaml, Kubernetes, all of this extra stuff that you need to get your head around in order to just start developing. Quick note about me. My name is Shai Wasserman. For the past 5 years or more, I've been working at TerraSky. TerraSky is a global solution integrator, solving companies' complex infrastructure, platform engineering, and DevOps challenges. Thanks to domain expertise, value-driven planning, and successful execution, we provide companies the best of both worlds: enterprise-grade infrastructure combined with cloud-native agility and velocity, generating the optimal developer experience and time to market at any scale. My job titles have changed over the years to reflect my focus and expertise, from software engineer to cloud engineer, DevOps engineer, and currently cloud-native senior engineer. As such, I've both personally experienced firsthand and seen the struggles of developing new applications and features for your company. So getting back to the issue at hand, this initial development problem plagues even the mightiest of tech companies. This is Dave, by the way. He's the poor developer we're subjecting to this misery. Dave loves writing code as long as he can remember himself. He likes to learn by trying things. He's good at reading errors. He loves his iced matcha with pineapple and his night owl themed customized Visual Studio code with all the themes and plugins. But as things stand, Dave needs to check off a lot of boxes before being able to start developing. Finally, after 2,000 or so years, mission accomplished. But probably Dave is very frustrated. I'm sure some of you are familiar with this experience. Maybe you are Dave. I'm definitely seeing a lot of Daves here. This Dave makes Dave very sad. All he wants to do is be able to start writing code. But he's got a lot of this prep work before he can even start bringing that value that he was hired for to your company. Enter accelerator. Hasta la vista, lengthy onboarding for new developers. So what is it? How does it work? Why do we need it, etc.? Basically, this is accelerator is a smart templating of files and code. It allows the developers to be able to just start developing without all of that extra prerequisite and overhead. It gives the ability to provide boilerplate code of your company standards already in place, the infrastructure files to deploy in your specific infra, and all with security in place. Gives you that control to do that. So how does this work? How do we use this accelerator and get all this wonderful stuff? So let me show you in Dave's favorite place, his IDE. So TAP comes with several built-in accelerator examples. So let's take a look at one of them together. So first, let me show you. Here is Visual Studio Code, which you may be familiar with. And over here, I have a plugin for Tanzu App Accelerator. And everything here on the left are accelerators that I have access to. This is connected to my TAP cluster. This also exists here in the UI. Let's just go to, this is just like that because you need to refresh it. And over here, this is where the accelerators are under create. See, and it's the same thing. And we can actually search for the accelerator using a nice search bar here, such as this, or we even have tags as well to pick specific languages or technologies or type of application, and really however you want to use it. So these two of these are actually my custom ones, but the bottom two here, Node Express and Node Function, are ones that come out of the box with TAP. So we're going to take a look at this one, Node Express. Okay, this is one that comes out of the box. We have two configurable parameters here, a name, which is a default parameter or a parameter that exists for every accelerator by default. But what you put in as the value is customizable. Right now, the default value is Node Express. And this checkbox here for include TAP deployment resources. Now, what's nice about the UI here in the web console is we can also click on Explore File to see what would we be getting and generating without having to download the whole thing or setting up a Git repository, which are all amazing features for when we actually want to set up the accelerator. But we just want to, like in this case, showcase what we get. So this is nice. So I'm going to leave the checkbox unchecked for now and click Explore File, and let's see what you get. And bada bing, bada boom, we have, if you look here on the left, this file tree. These are all the files that we get for us after generating this accelerator. So just want to point out a couple of things here. First of all, this is the README. It's pretty short. And also notice that the name is Node-Express, which if you are intuitive would realize that is exactly the default value of the name parameter. We'll take a look at that, what happens when we change that in a second. And then also notice that there are no folders inside here. I wonder why I'm asking. But also, let's just take a quick look. It's a very basic server.js file, just so you understand what it is that we are, this is the purpose of this accelerator to begin with. Okay, so now let's see what happens if I change this to, say, demo. Let's say demo lab. And let's check this, include TAP deployment resources. Let's see now what we get. Boom, all of a sudden, first of all, a ton more content here in the README. You can see this demo lab, which is that name, got replaced here. And we also have these folders in the file tree, catalog and config. In particular, this config has this workload.yaml with, this is a TAP resource. That's what would happen when we checked off the include TAP resource. So we got this, we also got something in the catalog, and we also got more content in the README. So all amazing, very cool. Now let's see, I'm okay with these values. So let's create a Git repository right away with this generated file. So let's do that. I'm ShyWiz. And the repository, the name of the repository, we're just going to call the same thing as that name, demo lab, for the purposes of this. Next, and generate accelerator. And now it's going ahead and doing that. And since I've already set up the credentials beforehand, so this was able to do that. But that's just a small step in the setup of your cluster to begin with. And now I can explore the zip file, download it, and I can even right away have a link here to the repository that it just created under my user, which I had logged in with. And you can see right here, it has those files that we just saw before when we were exploring it. And you can see this was committed just now. Amazing. So this is very, very useful for getting started, but it's a nice showcase. What we want to see now is how we can actually get this to some practical value and not just an example. So let us jump back over to our slides here. So yeah, this makes Dave very happy, right? We want to let Dave focus on what he was paid to do, and that is to develop and bring that business value to our company, and not spending 2,000 or so years on, just understanding how to get started. So let's transition into how we can build our own accelerators now. So developing for developers. So it all boils down to this file called accelerator.yaml. We're going to do an overview first of what it looks like, and then we're going to dive into the actual code. We're going to talk, there's going to be three main components to the accelerator YAML file. And I personally think, and I'm sure you will agree soon enough, that the last one is the most interesting and challenging, but I will focus first one at a time, just so you can get an idea of each one. So here we have a very general accelerator YAML structure, very stripped out with a lot of the content so that it could all fit on here and not be overwhelming, so we can understand the structure. So at the top level, under the accelerator key, we have this section here. And within this section, this part, so basically all of that in here minus the options, this is the metadata. This is where you have the name of the accelerator, description, icon, and those tags that we were using before, which helps to navigate to exactly the type of accelerator we want to use. And now over here, we've got the options. Now the options we'll talk about in a moment about what we've got there. And then we've got this bottom section, a top level key of engine. Okay, and that's our engine. Now the options, boom, I'll let your eyes readjust real quick. I basically have that same, what you just saw before, but I've added in a little bit of content here into the options and had to, squish it in to make it fit on the page. But what we have here is just an example of what we have. And an option is just a parameter, ultimately. So we have a list of parameters, and the parameters or options have properties to declare, how it appears in the UI and other necessary data for that parameter, so we can use it. So as I was saying, options are basically just parameters. And some examples of those properties are like input type, which you would have something like, obviously, you could just have a text, but you can also have like a radio button or a checkbox, right? That's what you would put under input type. You have things like a validation reject. So you can provide that feedback right away to the developer as he's inputting values into the parameters, into the options, whether or not that value is acceptable based on your needs. And then you also have, a property called depends on. These are just some examples. Depends on is also a very useful tool, purely UI, and it basically will reveal, hide, or show options or parameters based on the values of other or previous options and parameters. So if you only want to show like choosing something, if they selected that they want such a thing. Actually, I'll just give an example. Let's say okay, give me database boilerplate code, and then like whether do you want that? So you would check it off, and then if you check that off, then it would show, okay, which database, MySQL or MongoDB, as a quick example. All right, so now back to our friend here, our accelerator.yaml. So the engine. So let's take a look just briefly, like what some content there would look like. And so you can see this is just like a very, very small snippet. We're gonna like jump in a moment, but just so you can understand. So when you look at it at a glance, you can already note which part is which section. Now, this is the main stuff. This is where all the logic, where all the magic happens. So there's a lot to cover here, and we won't be able to go through everything. So just bear with me, and the more you follow, the more it will become clear. So let's take a closer look. So let's jump over here. So this accelerator that we used, the Node Express. Okay, this comes out of the box with TAP, and you can also see all of these in VMware's Git that's public. So this repository here, all these files, you may recognize many of them. This is what the accelerator uses, right? We have our accelerator.yaml file here, okay? But everything outside of that within this repository is available for the accelerator to use to template or to take and generate and then eventually output and give to our developer. Okay, so just wanted you to be familiar with that. And so this is what that accelerator YAML looks like. I'm going to show you, we're going to switch over to my IDE in a moment, but just showing that you can see this here all online on the GitHub. Okay, and we have this much larger engine section, right, which is what we're definitely going to focus on. Okay, so let's jump over now to my IDE, and we will continue from there. Okay, so let's hide this real quick. Okay, so what we have here, right, this is the metadata section. Okay, we have our tags, display name, etc. And then here we have our options, right, our parameters. So as I mentioned before, that first one, that name parameter is a built-in one for all accelerators. So you don't define it here. In fact, it has its own parameter that you reference called artifact ID, but that's all purely documented, and you'll see it actually in just a moment. But the other parameter that's obviously not built in was that checkbox, whether to include tab. So you can see it's a checkbox, it's a Boolean, and the value default is actually true. We have this imports section, which we did not talk about, but we will get to later. So just trust me on that and ignore it for now. Okay, and now we have our engine. So I'm going to hide all of these so that it's a little bit easier to take in. So we have this first keyword called merge. Merge is everything that's listed in the engine, all these like keywords that you start with are transformations. That's what they're called, the proper lingo. And merge is one of the ones that, one of the main ones that you have to be familiar with, which there's merge and there's chain that are similar but different. And they are basically ways like you provide a list of an additional list nested underneath of transformations or tasks, I like to explain, of what to do. So let's just take a look at what these tasks are doing. So this first one is including, and it has a asterisk, so it's including all files, and then it has an exclusion. of a bunch of specific files. So we can understand that, intuitively it's taking in all of the files and then, removing some. So at this task, at the end of this task, you get a set of files based on this task. Now the same thing for the next one and for all that follow. This one is only targeting the package.json, right? That's only what's included. And then you have chain here, like I mentioned, it's merge and chain. It's basically a way of saying how to perform the following tasks. And we'll talk about the difference in a moment. But you do have to specify one of them. And then here we're saying, sorry about that pop-up. We're giving a transformation called replace text, and then some specific keywords, properties based on that transformation to change the static node express text here with the artifact ID, right? And that's the name that we provide, that default name parameter for all accelerators. Okay. And so on and so forth. Each of these do a set of tasks on different files. Okay, and at the end, it compiles all of them together in one way or another, which I'll explain in a moment, and then provides it to the developer. We also have, for example, these a keyword property called condition, which basically says that this task would only happen if this condition evaluates to true, which this is that checkbox that we talked about. I do want to point out, but I want to point out the README because that one is a important one to understand, but we will do that after I go over some of the transformations back in the slides. So let's do that. All right, so accelerated transformations, right? So the goal of the engine is to take the files from that accelerator repository root and apply all the listed transformations to produce a final set of files and give it to the developer. At the top level, you have things like include and exclude and composition operators such as merge and chain. The next slide, we will talk about the difference. Then you have more specific transformations such as replace text, which is pretty straightforward, YTT, which means YAML templating tool, which is an amazing thing. So if you often work with YAML and you don't know YTT, you should definitely check it out. You will love it. But that is another transformation that we have available for us within the accelerator YAML. We also have loop, which technically is a transformation as well, but on its own means nothing without writing something nested underneath some other transformation to loop through. We have rewrite path. So when you're giving the files to the developer, you can change the name of the file or even the path location. Otherwise, it would give it in the same structure and file name as what you have in a repository. So this gives us a lot of utility and organization as well. And there's many more. Like I said before, we can't go through all of it, but I want to give you a sense and give you, try and get your hands dirty as much as I can. Okay, so now merge and chain for dummies and scholars, because it's not super straightforward. Basically, it's a declaration of how to perform the nested tasks or nested transformations that you give underneath the merge and chain. One of the main differences, I guess, or maybe the main difference is that one does things in parallel and one does in sequential order, the tasks that it has. So the merge, the parallel one, each nested task or transformation gets the same set of input files. In other words, everything that's available, all the files that are available at the, let's say the indentation of where you declare merge, all of those are available to use for each nested task. And then is given to each of those nested tasks. Okay, and then each of those nested tasks or transformations does whatever operations it has. And at the very end of the merge, all of those nested tasks, the files get merged at the end, hence the name merge. Chain on the chain on the other hand, it does things sequentially. So again, all the files that are available at the place where you write chain is inputted and given to that first task. And then every task or transformation after that gets the output from the previous one. So if you change a file in the first task, then that file is already changed and given to the next one. Whereas in merge, you have that, if you change a file in the first one, that doesn't appear, the original without the change is given to the second or any of the other tasks. And each of these merges and chains can have nested merges and chains, which will become more understandable as you work with it. But it's basically you need to have it in order to say, okay, how am I performing the following set of transformations and tasks? In what order and what do I do at the end? So let's let's make some changes. We'll actually, right before we go into the changes, I will explain that README part because that's important for us to actually implement these changes. But just so we don't have to go back and forth, let's talk about which changes we'll make. So let's add in an option to include database boilerplate code into our Node Express project accelerator. And we'll give a choice of database depending on if they choose to have the database boilerplate code, and it'll be a choice of MySQL or MongoDB. Whoa, big surprise. Maybe that was the example I said before. Anyways, back to the code. All right, so as promised, let's just quickly go over this last section here of the README, okay? And what this task does. So now they have this type combo, okay, which I don't want to get into too much, but basically we're using combo in each of these tasks, right? This one is using combo, this one's using combo. All of these are using combo implicitly, as opposed to explicitly as it's written here. Why they chose to explicitly write it here, I'm not sure, because it would work without it. But it is worth noting that combo is basically a set of transformations that are a typical and does things in a typical flow. And if you don't specifically write some of those transformations, then it has default values. Don't worry about it too much. If you are interested, there's a nice documentation online on what exactly is going on over there. But if you didn't want to use combo, then you would have to be writing a lot more code and you wouldn't have access to these like first class level keywords like merge. You would have to say instead type merge, but never mind. So what is important to note here is we have this keyword called on conflict. Okay, now this is something that is what we have available access to this even without writing the type combo, but it is because we are using type combo, and it's basically saying, okay, if there's any conflict, if we end up with the same file in the following tasks from separate tasks, what do we do? So by default, combo uses a like use last, right? But here we're saying to change it to append, okay? And we're actually using this on purpose to gain a benefit. So let's go and see what we do. So we have a merge and we have two tasks, right? See here, 1, 2 within the merge. Okay, first one, we're taking the README file and we're replacing the text. Okay, nothing too interesting. All right, we're just replacing that text. But the second one, this deploying.md file, which we haven't seen in the generated files, right? So this is only occurring on condition. So when we check off that include tab resources, and then, okay, it does the same replace text, right, of the name with the node express, some static node express text with our name, and then a rewrite path transformation to readme.md. So that's exactly what we have here. So at the end of these two transformations or tasks underneath the merge, we end up with two different readme.md files. So without writing this on conflict depend, by default, we would only get the contents of deploying.md as a readme.md. But here we're getting both. But the first one, the second one is appended to the first one. And this is how they achieved that. If you remember when we checked off that, use the tap resources, how we had a lot more content in our README. So we're going to be doing a similar thing in our example. So let's jump right into that. I did this just to save some time. Okay. So this is what we have, right? This is my file, but I took exactly that same node express, and that's everything that's here. So what is it that we want to do? Remember, we want to add in an option for DB boilerplate code with choices of MySQL or MongoDB. So let us add in some options or parameters. Call this one include DB. And this one should also be a checkbox, a Boolean, same as the one above, but we'll have a default value of false. So by default, we're not going to include DB. Again, that's just pretty straightforward. Now, we'll have another parameter or option called DB type, okay? And this one will do an input type of radio, so they can only select one within the UI. And we only want this to be visible when the include DB is checked. So we'll write in this depends on, and reference the include DB option. Now we need to give the choices of MySQL, just scroll down a bit, and MongoDB. Amazing. Okay, now the next thing is we want to, within our logic, right, when we get to actually using this stuff in the engine, right, and we're putting in the conditions. So to write this, we'll need to also say, if include DB is checked and the DB type is equal to MySQL, or if it's equal to MongoDB. So there's a lot of the content there that we don't necessarily want to write, many times, and certainly within the engine where it could get complex, very complex anyways. So we have this very nifty property called let within the engine, which just allows us to basically declare some local variables. So we will have one called MySQL with an expression, a spell expression, everything, all the expressions in accelerator.yaml are spell expressions. There's documentation on that, so you can definitely look it up and see how that works. I also got a tip once that if you needed some assistance with writing an expression, you could use some AI things like ChatGPT to help you write those expressions. But maybe there'll be some dedicated, maybe there is some dedicated tooling for that. But just so you know, I personally have a bit of a tough time with spell expressions. So we'll have one for MySQL and one for MongoDB. So now we can just use these local parameters for our conditions instead of writing out this whole expression there, especially if we might have to write it multiple times. Don't know. Before we continue, I just want to show you, I have already put in this folder, this additional folder, in addition to everything else that was already in that repository for Node Express. So I added this folder called template modules, okay? One from MongoDB and one from MySQL. They're identical in purpose with slightly different code. So we have these 3 files in each one: an import, an init for initialize, and the module itself. And this is all like Node Express, basic boilerplate code. So what we want to do is we want to have this file, the module itself, right? So for example, this one for the MySQL, okay, whatever, we want this additional file. And in our server.js file, we want to add a line we want to add some lines or a single line at the top to import this module. And then we want to initialize this at the end of the server.js file. Just for a somewhat practical example, right? So our import code is just this singular line, right, that we want at the top of the server.js file, and this initialize at the bottom. It's the same thing in the MongoDB, but with some slight variations. Obviously, MongoDB instead of MySQL implementation. And just for reference, this is what our server.js file looks like. All right, so back to our accelerator.yaml file. Let me close this. Okay, so first thing is we want a condition. We only want to do this. We want to do one for MySQL condition and one for MongoDB. So it'll be basically the same. So let's just focus on the MySQL one. And we're going to follow a similar pattern as what that README had done and use this onConflict append. Notice how I'm not declaring type combo because it wasn't necessary. It's implicitly used. And then we'll have a merge. And now what we're going to do is we're going to include the first thing that we want at the top, right? Is we want that the import of that module. We want that at the very top. And we need to put this to the server.js file. So we're going to actually do a rewrite path of this file to server.js. So at the end of this task or transformation, right, we will have a server.js file with just that like single line of importing the MySQL. Then we will include the actual server.js file, which now, because both of those will output a server.js file underneath a merge, and our onConflict thing was changed to append, so we will get the main server.js content appended to that import line, which was also now a server.js file. There's multiple ways to achieve these types of things within the accelerators, but it's really up to you on how you want to implement it and what makes the most sense. I think in the near future, there's going to be put out documentation for common practices and patterns. And then lastly, we need to initialize the MySQL. So we again are going to rewrite that path to server.js, and that is therefore going to get appended at the end of this merge. And we're going to have one more task here of the module, because we need that. Now we don't need to rewrite it to server.js, right? We certainly don't want to do that. We want it on a separate file. So we will rewrite it to something that makes a bit more sense and within a modules folder instead of template modules. There's also a little regex here, which is superfluous, but I just wanted to point out that there are multiple properties that you can also use. For example, this one has a regex that allows you to specify more specifically what you want to rewrite. So if you didn't want to rewrite the path of everything that you get included, all the files that are available to it, because this would operate on all files otherwise that it has at this point. But because it only has this one, so that's why it's superfluous. And then we'll just add the exact same stuff, structure to the MongoDB. Okay. So now I'm just going to quickly push this to my Git repo, right, and reconcile this accelerator, which it would do after some time anyways, but I want to do it faster. There's different practices for developing, which allows you to just straight upload and has special flags for reconciling, but this is how I had set up this cluster, and so this was easy enough for me. So this is my accelerator, and we can see we have a different value here, this of the name, but that's not so interesting. What is interesting is this. We have this checkbox for include DB code boilerplate. And if I check it off, oh, now we have an option from MySQL or MongoDB. And if I click, we'll do MongoDB this time actually. And if I click explore file, we can see. So it took that name and put it here in the same way, right? But what is interesting is here in server.js, which is missing the main server.js data. Well, we have our import, right? And we have our initialize. So, right, and this is our module. So what's very interesting is we can also actually see the log of the accelerator of what it did to understand more what happened. So we already know what we're looking for. So let's do server.js. Okay. Okay, didn't match, right? That's the deploying part. That wasn't interesting here. So this one, info will include, yeah, server.js, right? Debug model for pass will concatenate them together. Yes, that is correct. So what appears to be the issue? This is the correct one that I pushed. We included here. Oh, okay. So here we have in our MongoDB just a small mistake where we don't have the server.js file. Here we do, it's just in the wrong space. Boom. Okay, very simple fix, right? This is the structure that we actually have. Some live debugging is always a lovely thing. So let's push that. Bada bing, bada boom. And reconcile that. Okay. And refresh this. Okay. And now let's see if we got it right. Explore file. Boom, there we go. Yeah, so we have now, right? This is our import. This is the rest of the original Express, Node Express code and our initialize. Okay, very cool. So there we got to see a little bit of live debugging as well. Which, by the way, that file here of the log, I think they're going to be improving the readability of it, so it becomes even easier to manage. Amazing. Okay, so where is our presentation? How are we doing on time? All right, we will rush through the next section. So let's make a few more changes. let's say we want to use this DB implementation that we wrote in other accelerators. So we have something called fragments, which is sort of like miniature accelerators that we can, reusable accelerator snippets, as you see right here, that we can then put into different accelerators. Think of it like, functions almost. And how we would use it is, if you remember from the previous thing with the imports section that I was talking about, right over here. So I don't know if you can see my mouse, but if you look on the right side, so that imports, you need to add in that to say which fragment you want to be using. And then within the engine itself, you would say, you would use a transformation of invoke fragment for when you would want to use it. Now, one thing to note is that where you declare to use the fragment within the engine, it's scoped to that space, meaning any of the files that are available at that point is what will be available to the fragment. So we're just gonna breeze through this real quick. So let's take a look at a fragment. So we have here, so this tab workload was a fragment that they were using, that whole adding in that workload.yaml within the config folder, I believe it was, or let's see, what was it? The config folder, right? That's this. So that whole thing is from a fragment that's also out of the box with tap. So they had imported it and then they had used it actually over both here in the config workload and the catalog info. Sorry, not the catalog info, just the config. Here we go. See, invoke fragment. Okay, and a special reference. So there's all these keywords, all documented for each transformation. So what I have done ahead of time is I've created this fragment called GitHub tap blah 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 blah, and it's basically just taking that whole code that we just wrote at the end and putting it into a fragment. So let's just grab all of this. Okay, because all right, and delete that and all. So the fragments also include any options, parameters that are listed there. So let's get rid of that as well. Let's uncomment this, right? So now we're just importing this additional fragment. And all we're doing is adding this one lovely piece of code, invoke fragment. Okay, so let me just commit and push that. Okay, and let's also reconcile that. And I'll just show you what that looks like in the fragment. Okay, so this is the fragment. This is all of that engine code that we see, right? The let and these additional options, the include DB, et cetera, and like we just took all of that we just made and threw it into a fragment and just, referenced it and invoked it. And so now we close this and refresh this. So it's exactly the same. In fact, maybe this will show me that previous error. Yeah, so like there's like an error over there to show that it has in fact changed. But the idea is that we basically, so it's duplicating it. So I have a small duplication there accidentally, but you can see that it is in fact different. So it's not using that original code. And basically we were able to just take out that fragmented piece of code of the accelerator and scope it out differently. Now we could use that fragment in different accelerators. As I mentioned before, right, combo is this implicit transformation that we're using everywhere. It has part of it include, exclude, merge, chain, all has like some default stuff. So I won't get into it too much, but there is much better documentation online for that. So one last thing before we take questions. So how did this all sync up with Git? So I've shown you already a few of these things. What I have set up was a GitOps approach for managing the accelerators. And I'm going to show you real quick in my tap values YAML file what I needed to do in order to set that up. And ultimately, it's pointing to a Git repository that we then have a list of manifests, which is basically a list of the accelerators and where to find them. Each accelerator itself has its own, section. You don't have to separate each one by a repository, but each one needs to be within a repository. And we'll also take a look at the repo structure. So let's just very, very quickly, since we're super out of time. Okay, so, all right, so here in my code, I'm just going to show you my tab values, okay? And this part here that I've applied to my cluster, so this is where I'm saying, hey, this is where my accelerators are located. So it goes to this Git, and I'm telling it where within it, and I'm obviously giving it some secret so that it can actually access it, since it is a private repository. And then, so I have it already up here, not this one. Right, tap accelerator demos, that's this one right here. So this is the repository that it is referencing, and it's pointing to accelerator/collection. So accelerator/collection. And then here I have a YAML of all the different manifests of my accelerators, right? And each one has its own pointing to its own Git, which I happen to use the same Git, but you basically can have it however you want set up there. So this is how that part's set up. And you also do the same thing for fragments, by the way. See here for fragments and here for accelerators. For future reference, I've got a bunch of links here for some amazing stuff, documentation. So if you want access to these links, you can also easily find them online, but these are some additional content for reading. So any questions? Second, let me pull up the chat here. Hold on a second. Let's see, where is it? Okay, so we've got, can it support any language? Yeah, it's language agnostic. I mean, it's however you write the accelerator itself is going to manipulate the files that are there. Any of the files can be written in whatever code you want. Some languages such as Java have more built-in functionality, like Open Rewrite, which I didn't get a chance to talk about, but has some very powerful first-class utility there with Java. What IDEs are supported? Visual Studio Code and IntelliJ. And I imagine more on the way, or by the time you watch this, maybe already more, but those are the ones I know for sure. Yeah, so that there was this type called provenance. Let me just jump to one of these accelerators. So yeah, this transformation at the bottom, provenance. It's a special transform that is used to generate some details about the execution of the accelerator, like what was generated. Like I could show you actually just right here in the Explorer file. So because it has this has a provenance thing in the accelerator YAML, so it provides this accelerator info. So it has an ID, a timestamp, you know, who did it, what was the source, and et cetera, like the parameter values that were given. So it's very useful for just keeping track of that. Yeah. And best practices. So there's definitely a lot of documentation on best practices. It's still like, you know, within the early stages, so more and more documentation is coming out for those best practices, and I imagine common patterns. I mean, if it doesn't come out, you know, via VMware, then I'm sure the community will. So I'm not too worried about that. Anyways, we're super out of time. So thank you so much for attending my webinar. Yeah, thank you. To stop the recording now.